She's there, Priya. Priya, you can start.
Yes, ma'am. Am I audible and visible?
Yes,
Yes.
yes.
A very good morning to one and all present here. I am Riya Modi from second year Biomedical Engineering Department. It gives me immense pleasure to extend you a warm welcome on behalf of the Department of Biomedical Engineering, BMSA and BMESI. Thank you for joining us today for the last webinar session from the series of 30 hours credit course, that is BMESI sponsored certified course on medical devices, manufacturing and regulation. Topic for the last session is demonstration on testing of calibration of medical devices by Mr. Deepak Raina sir. Now, I would like to welcome Dr. 𝒒𝒐𝒐𝒏𝒄𝒆 sir, HOD of Biomedical Department and all other respected faculty members for joining us today. Thank you so much for joining us and honoring us with your virtual presence. Now, I request Dr. 𝒒𝒐𝒐𝒏𝒄𝒆 sir to continue further.
Yeah, good morning all. Especially good morning Deepak Raina sir for joining us today morning with though he has taken time from his very busy schedule. Actually, today's topic I think is on importance of testing for biomedical equipment. Yeah, there is a slight change in the topic which Raina sir has suggested, importance of testing for biomedical equipment. And I welcome Deepak Raina sir, who is a zonal manager north and west for Fluke Biomedical. He's a very renowned personality in testing equipments which are used for testing of biomedical equipment. Uh, I will not take much time, but I will give you an example. When I started my career as a biomedical engineer in municipal corporation, maybe you can say around 20-25 years back, we were used to repair these biomedical equipment, and the always thing was there we have repaired the equipment, or it has been maybe repaired by the company, but who will go give the guarantee about the output, what is expected? Yeah. So in search of that, we found one company, Biotech Equipment USA. They were manufacturing this type of equipment. So we purchased few equipments from them, including Defib analyzer, ECG analyzer, ECG tester, so many 10, 15 different types of equipment, and we started working on that. And then we came to know, understand that these are very important. Only one example I will give you. Suppose you say that during this pandemic situation, we are using the ventilator. The ventilator basic setting is of a tidal volume, right? And when we are setting a tidal volume, and suppose after maybe a few hours of working, or maybe certain, we want to see whether the ventilator is in a position to deliver the same volume or not, electronic is perfectly or not. Then we used to this equipment and it used to tell us, yes, whatever volume is delivered by the ventilator is correct as per the setting. So this is one of the example. I will not go in detail because this is a great topic by Deepak Raina sir. So once again, without wasting much time, I will welcome Deepak Raina sir. Thank you very much for accepting our invitation, and I'm handing over it to back to the organizer, maybe Rutuja or Ria, who will just introduce Raina sir in detail. Yeah, please.
Thank you so much, sir. Now, I would like to give a brief introduction of our guest speaker, Mr. Deepak Raina sir. He is a business development and strategy planning professional with experience over 17 years in sales and marketing of analytical equipment and medical equipment, profit management, product management across industries like government and private hospitals, laboratories, etc. Sir has given Sir has driven business through targeted business development initiatives with focus on both top line growth and bottom line growth. Mr. Deepak completed his diploma in Electronics and Communication Engineering from MG College. Deepak sir is zonal manager in North and West India, including Nepal at Fluke Biomedical, US MNC Fortune 50 Group 4F Corporation. Apart from all the achievements, with his brought up enthusiasm and persistent efforts, he is regional manager at BTL India Private Limited and regional sales manager at Skytac Systems India Private Limited. Now it's time for the speaker to take over. So, sir, can you continue?
Yeah. Thank you very much. Let me share the screen first, then
Yes.
can you
Yes, sir,
see
it
my
is.
screen?
Yes, sir,
It's
it is
visible?
visible.
Okay. First of all, I would like to thank Dr. Jitendra Thorvi and his team for inviting me to this nicely organized session. Today we will be talking on some of the important aspects of what is the need of sorry, just a minute. Importance of testing for biomedical equipments. As you have already introduced me, so let me talk something about Fluke Biomedical. Fluke Biomedical is it's a group of Fortune 50 company, and we have almost we are everywhere in the field of Fluke Biomedical, RaySafe, Landier, or our brands, where you can trust on us for all these kind of biomedical testing. Even radiation safety instruments are there. We have complete solution for the hospital management and all. So today we are discussing on the importance of testing for biomedical equipments. What is the need for testing? See, nowadays, if you see, we are dependent on variety of medical equipments for diagnosis as well as for therapeutic and follow-up actions. So you never know if I am being tested, if I am being diagnosed with some problems. So we have to take the treatment in the hospital. Suppose my blood pressure is high. What we do normally in the hospital, doctors will say, okay, we will check the blood pressure, then we will monitor it, and then accordingly we will prescribe the medicine. But do you have any idea, like when that instrument was being tested for its own performance, kind of thing, whether it was 5 years before, or but you are dependent on that totally. If it is 120 by 80, it is your luck. If it is 150 by 100, he will start prescribing medicine to you. But by only giving feedback for signal by the equipment, that blood pressure monitor, you are being treated by doctors. So sometimes what is happening, if that particular instrument is not tested properly, is not calibrated, it can give any kind of result, whether it is good or bad. It can be bad also. And then, but doctors have already started prescribing you medicines, which is actually may be required and may not be required also. So that is why, unless properly tested and calibrated, the outcome of diagnostic equipments and effect generated by therapeutic equipments will be error prone. It is always there. Therefore, regular testing and calibration is very important to do before you start any kind of procedure on the patient. So this is about Fluke Biomedical, what we have already discussed. So this is actually, we are everywhere in the medical field. If you talk about testing, kind of, we are having 15 global authorized service centers worldwide, backed by a global Fortune 50 company, Fortive Corporation. And now, if you see, this slide will tell you exactly the hospital quality assurance management. Like, as you are all biomedical engineers, maybe after completing your course, you will be engaged in all these kind of hospitals for your jobs. So if you see, all the departments will be requiring all these equipments. Hospital equipments are there, like in the emergency rooms, you will find defibrillators. Cardiology, you will find lot of equipments, even cardiac monitors are there. This voice is, I think, can you please unmute? Yeah. Then diagnostic imaging centers are there. Intensive care units are there. NICU are there. PICU is there. That is pediatric intensive cares. So we have a lot of equipments inside. And what we are having, Fluke Biomedical has a total solution for all the hospital segments. Now let us talk on the very important subject today, medical equipment standards and parameters to test as per IEC standards. You know what is IEC standards is basically it's a International Electrotechnical Commission. It is basically a body comprising of medical professionals, doctors, engineers, scientists, metrologists. They have designed a document, IEC, and worldwide all manufacturers are following that particular standard while designing R&D, production. So they have to follow all those things to maintain the quality within the system. I have made this slide in one. This is a very, if you see in one slide, you will get all the information. So if we are talking about the modality, if we are talking about the hospital equipment, which we are saying device under test needs to be done. So we have different in the left column, you will see equipments of what are our simulators, analyzers can do on the you can say, our equipments are basically working as per the are the standards actually. And hospital equipments are the DUTs, device under test. Suppose you want to test a monitor. What will you do? There are IEC standard says you have to do two tests for one is electrical safety test and second is performance test of the equipment. Electrical safety means whether your equipment is safe for patient use or not. If your equipment is not safe for patient use, please rectify it, repair it, then again do the testing. Once you ensure that it is fully operational, it is fully it is as per it is meeting as per the standards, you have to say then only you can use that particular machine on the patient. After that, once you have ensured that electrical safety part is fine, now secondary it comes to performance parameters. What are outputs you are generating from the machine? Like suppose we are talking about a patient monitor, which is commonly used in all hospitals. So once patient is admitted in ICU, doctor only monitors vital parameters on a patient and he starts prescribing medication, treatments, procedures based on those vital parameters. You can say blood pressure, ECG, respiration, SpO2, pulse oximetry means SpO2 is, pulse oximetry. So if those parameters are not correct, if your equipments are not delivering proper results, then there is an issue. Your hospitalization will increase. You will be admitted in hospital for a longer period of time. Expenses will be more, and most importantly is, there are, your life is at stake. That is the problem. So just to ensure all those things, whether those equipments are working fine or not, these simulators are used as per IEC 60601 and 62353. Let me tell you, IEC 60601 is mainly designed for manufacturers who are making, who are designing or producing equipments. Like if you say Philips, GE, They use normally IEC 60601. And when it comes to field services or at a hospital, suppose you as a biomedical engineer, if you are working in some hospital, you can use IEC 62353 because you need not to do from top to bottom, like which is in IEC 60601. So you need to do 4 to 5 vital things to ensure that your equipment is safe for patient use. Like suppose we are talking about, and please remember this, IEC 60601 is common for all the medical devices. If you have one electrical safety analyzer, you can do test for all the medical equipments, which are single phase equipments. Okay. So now what are you going to measure? Leakage currents, protective earth resistance, insulation resistance, touch currents. You can see what is the current consumption, applied part leakage. We will come to that in the next this thing. Now, same way, vital sign simulators, you can test DUT with NIBP, IBP, ECG, respiration, SpO2. And on the extreme right, the column which I have mentioned, those are the standards which you can say. Suppose if somebody wants to do monitor test, patient monitor testing, so he has to follow IEC 60601-1, that is for or 62353 for the electrical safety part. And for the performance part, he has to follow IEC 60601-2-49. So those are the performance standards. Accordingly, we have infusion device analyzer. You have to measure flow rate, volume, occlusion. Suppose if I am saying why it is very important, infusion device analyzer. Suppose you might have heard you are overdosing a patient or you are low dosing a patient. Have you ever heard people, patient died because of overdose? Because see, when doctors are prescribing any medicine, those are precious, medicines. Suppose you take a, some cancer patient. Those, medicines are very costly. So what doctor is saying, you give 10 ml in 1 hour. If that 10 ml goes in 15 minutes, so that means infusion device machine, which is there in the hospital, is not working properly. So with our IDA 1S, you will ensure whether that is working or not. It will pass and fail that equipment. If that is working fine, then no problems. If it is not working properly, it will give 10 ml in 15 minutes, then you are overdosing a patient. So this is why, it works like that. Volume, suppose if you are giving 10 ml, if it is not delivering 10 ml to patient end, what will happen? You are not delivering enough quantity which is being prescribed by. So there is always a problem in that also. Same way, defibrillators. You give electric shock to the, to make your, heart rhythm normal when it is abnormal. So you have to check energy. Suppose if I am giving 250 joules to patient, whether 250 joules is being delivered to patient or not. At that time, what is the ECG waveform? Charge time. Suppose we claim charge time has to, you have to deliver, you have to give energy in 6 seconds. If it is delivering in 15 seconds, it's of no use for patient. So these are all specifications what manufacturers have published in the catalogs, and they have to meet all those with these kind of simulators or analyzers. Similarly, as we discussed just now, Dr. Jitendra also discussed that gas flow analyzers, ventilators. You have to see minute volume, tidal volume, oxygen concentration, respiration rate. Okay, PEEP, inspiratory pressure, expiratory pressures, all those things you have to check. Suppose if oxygen is we are delivering 100%, if it is only going 60%, so you are not giving enough oxygen to patient. So similarly, electrosurgical unit is there. Then incubator analyzers are there for incubator testing, warmer testing, phototherapy radiometers. Like you have seen phototherapy machines. So on the right, extreme right, I have mentioned all the standards. So this is a slide, which is running from for past 5 minutes. You can just, note down all these things, or maybe, I can send it across later on. And your this, faculty may, they can circulate it among you. Yeah. So let us come to medical equipment quality assurance electrical safety testing. Introduction is basically why we are doing electrical testing to, topic of paramount importance is medical device quality assurance best practices. Electrical shock can cause disruptions during healthcare procedures, resulting in injury or death. Suppose if my equipment is giving leakages above the permissible limits, what will happen? I have a next slide where you can see what are the limits, which are the what are the dangerous limits and what are the permissible limits for our practices. So physiological effects is if you are getting a tingling sensation, it's okay. Serious burns, cardiac fibrillation, muscle contraction, suffocations. See, this is a typical example. If you see, this chart will tell you everything. 10 milliamperes to, okay, from 100 milliamperes to 90 amperes, if you see, that is a danger area. Burns will happen, cardiac fibrillation will happen, muscle contraction, suffocation. This should not happen when you are using a electrical safety. When you are using a device, if it is having leakages more than this, then it is not a good sign that equipment is not good for use. You have to cross check, you have to repair it, you have to report that it is a faulty equipment. Please don't use that on the patient. If equipment fails, it has to fail in the biomedical department, not in the ICU, not in the OT. Please remember this. This is a job of a biomedical engineer. So worldwide standards have been established to limit leakage currents. So this is the main agenda why IEC is being framed. They wanted to ensure that minimum, leakages are there, and those are there within the permissible limits. Basic electrical safety test is visual inspection of cables. You can do whether there is any wear tear is there or not. You cannot use those kind of cables. Measurement of ground wire resistance we can do. Measurement of chassis and patient lead contact isolation. Have you ever seen if you see, if you go to any place, if you touch any instrument, it gives immediate shock to you. If somebody has experienced it, so that also should not happen. So those things we have to ensure that those equipments needs to be verified for all those things. Worldwide standards have been established and differ in criteria, measurement and protocols. If you see International Organization for Standardization, ISO, and IEC, we are talking about IEC today. Protective earth resistance, like if you see for electrical safety, we have to do a lot of tests, but these are the tests which are of most importance. Protective earth resistance we can measure. earth leakage currents. As I said, touch and enclosure leakage current. Suppose if you touch any instrument, it should not give any kind of shock to you. So for that, this standard is there. You can very well check all those whether it is within the permissible limit or not. If it is not, then please report it and get the equipment repaired. And after you repair the instrument, then again you have to do the test. That is the protocol. Then patient auxiliary leakages. Now, if you see on right side, there is an ARMY. That is another standard, which is normally we are using IEC 60601 and 62353. See, these are all the same things, but only the terminology is different. Protective earth resistance we say in IECC, and here we say ground wire resistance. So those are the differences only, but tests are one and the same. How many of you might have seen these instrument classifications? If you go to any hospital, if you might have used any equipment, like you might be doing in your college also, those testings and all. On right side, if you see those yellow color, those signs are there. You will find these kind of labels on each equipment. That will do the classification of every equipment. Like suppose if you have a class 1, class 2, class IP. By these signs, you will come to know what kind of equipment is this. It is a manufacturer has to mention it. It's the mandatory for them as per the IEC standard. Suppose if I am talking about class 2, live part covered by double or reinforced insulation. Why we are using double insulation? Why not single? Suppose double we are using because just to protect it, because we wanted to have a minimum leakages, shocks from the equipment. So if first insulation is failing, so we still have second to protect that. So that is, equipments are also sometimes, like that. Then class IP is internal power supply. 𝒂𝒏𝒄𝒆 analyzers, 𝒂𝒏𝒄𝒆 machines, 𝒂𝒏𝒄𝒆 machines, electrosurgical units, what are used in hospitals. You can say that is a typical example of class IP. Then after that, we have applied parts or lead type. What does it mean to you? Type B, patient applied part earthed. If you see this kind of, heart is meant there, no? Heart is there, no? On the right side. If you see this kind of sign on the equipment, you should come to know that it is a type CF, which is very close to heart. That means, and type CF is like, suppose we have an ultrasound machine. We have defibrillators. Those pedals are very close to heart. So that makes that device as a type CF. Type BF is again, there is little bit, they are similar in this thing. But type BF, again, you can see incubators, all those things are, you can say those are BF. So you have to judge all those products by seeing the sign. And you will have to really, if you have a IEC 60601 document, you can go through that. Your, you can just see where, if you can get it from somewhere. This is a very beautiful document. You can just read it and you will come to know about all those, what is type B, type B, F, CF and all. And you can see the, examples by seeing, practically, equipments also in the hospitals. Electrical safety standard, like we have some standards inside, like National Fire Protection, as I said, NFA, Army, Then we have IEC 60601, 62353, and UL is underwriters laboratories. We can perform all those standards from our equipments. Suppose if we are talking about the hospital environment testing, like under IEC 62353, you can start. See, this is a diagram which has been given as a testing requirements and sequence according to IEC 62353. You can start selection of the test, visual inspection. As I said, you can see whether the leads are fine. Protective earth resistance you can check. Then you can check leakage currents, insulation resistance, functional tests, then reporting of results. Evaluation, you have to do evaluation also. Then check and prepare for normal use. Then again you can set it to the next test. Estimated time what is taking for electrical safety is 5 minutes if you do a test with ESA 615. See, this is a classical example. If you see the image, it shows how DUT is connected to our ESA for testing. White color on the left side, you can see that is a DUT of that is a machine, hospital machine, defibrillator, you can say, or whatever. Then we have electrical safety analyzer. So you can connect that DUT to our analyzer. I will show you a video also after this these slides. Then you will come to know how it works actually. So you have to ensure before you do the test, there is no physical damage, display etc. is okay, switch and control is operable correctly aligned. So you need to check all those things before you start a test. Then you can do a setup. So you have to ensure always that once you do a setup, the red color probe which you are seeing on the ESA, you have to make a zero, resistance of the leads, because if you are not zeroing the lead, what will happen is whatever the measurements you are taking from the DUT, that will add on to that particular measurement, and it may increase the there may be slight increase in the output value. But to ensure that once you zero it from the ESA, then you take the actual measurement and that will show you the perfect value. Ground wire resistance, you can say, if you are taking this, then you have to connect this crocodile red color probe to accessible part of the earthing. Then you can very well see how much is the ground wire resistance. Accordingly, you can see the mains voltage, whether the mains voltage is correct or not, earthing is proper or not. Our equipment can detect all those things. Insulation test. Again, mega ohms is there is a button, you can press that and it will tell you the insulation values. How much, like there are two test points. One is 250 volts and another is 500 volts set by IEC standard. So it shows that if your equipment is passing at 500 volts or not. So it should give about 2 mega ohms value. So our capability of our equipment to measure this is up to 100 mega ohms. So if any value above 100 mega ohms is there, our device will display OR, that is over range. Means your insulation is very good. Settle if it is above 2 mega ohms, your equipment insulation is very good. Suppose if it is measuring 10 mega ohms, settle your equipment is okay. But it should not go below 2 mega ohms. If it is below 2 mega ohms, then your equipment is fail. If one parameter fails out of 10 parameters, still your equipment is fail. You cannot use that particular equipment on patient. Please remember this. Again, same as I said, equipment leakage currents. You can perform the leakage currents on the touch currents are there. All those currents you can verify, you can check, and you can measure all those things. And one more thing here, what you can also do is you can make a single fault also. See, what we are doing is we are doing in a normal condition also the testing, but you can make neutral as a phase and vice versa you can do. You can reverse the polarity, then still your equipment should give the readings. Maybe there are some different permissible limits, which I will show you in one format. What are the permissible limits for single fault condition and normal condition? So those has to be followed actually. Patient applied part leakage currents. This means that suppose if you have a ECG machine, ECG leads are there. You can check one by one what are the leakages on each lead. Like if you have 10 leads, you can measure one by one on each for all the leads. It will tell you what are the leakages, whether it is within the permissible limits or not. This is a report format which normally these are the permitted values. They are the parameters. Ground wire resistance should be less than 0.3 ohms. Chassis leakage, like as I said, enclosures, you touch currents and all, it should be less 100 microamperes. NC, what I was discussing, NC is normal condition. And less than 500 mega ohms, it is SFC, single fault condition. As I said, if your neutral is not at a neutral place, it is in phase, then it is a single fault condition. You are making a single fault condition, then you can have this kind of permissible limit. Again, same as I said, if you have patient leakage currents, again, B and BF type, as I mentioned earlier, those are the equipments depends upon the uh, body parts, So less than 10 microamperes for CF and patient leakage current isolation test less than 100. This is the criteria which you will find in IEC 60601 and 62353. Those are the permissible limits. You can see to those limits anytime. Then measured values. And what is the deviation? Remarks, whether it is pass or fail, you have to give that report. Suppose if out of these 5-6 tests, one parameter is not passing, the remark should be your equipment is fail. You cannot use it unless and until you don't repair it, you don't verify it, you don't rectify that fault. After that, again, you have to test and ensure that you have all the remarks in pass. Then you can give that equipment, hand over that equipment to OT people, ICU person for further usage on the patient. This is a one subject. So we have done with this electrical safety part. Now, after that, we will come to performance part of the equipments. Can I have the video, please? This is for electrical safety analyzer.
Sure, sir.
Yes,
Just a minute.
Please unshare your screen.
Yeah. Please.
𝑰𝒎𝒂𝒐𝒓𝒕𝒂𝒏𝒄𝒆 Electrical Safety Analyzer represents the next generation in biomedical equipment testing. Portable, lightweight, and designed for operation in tight spaces, the 𝒎𝒂𝒐𝒓𝒕𝒂𝒏𝒄𝒆 offers the functionality of a simulator, multimeter, and electrical safety analyzer in a single test tool. It's all about making your job easier.
Can you make a big print
For a
on
closer
the
look,
total?
the tilt stand feature allows the 𝒎𝒂𝒐𝒓𝒕𝒂𝒏𝒄𝒆 to adjust to your working environment. And even from a distance, the information you need is easy to read on a large display screen with adjustable contrast. The ease of use doesn't stop at the housing. The 𝒎𝒂𝒐𝒓𝒕𝒂𝒏𝒄𝒆 has an intuitive interface that can guide you through a number of standard electrical safety tests. And this versatile product can be used worldwide for compliance testing to preventative maintenance electrical safety standards of choice. Featured tests fall under a few simple menu keys and include protective earth or ground wire resistance, equipment current, mains voltage capable of 120, 220, and 240 volt applications. Testing insulation resistance is just as easy. Dual lead point-to-point testing includes measurements of voltage, resistance, and leakage. Leakage tests per worldwide electrical safety standards include ground wire, chassis, lead to lead, applied part, lead to ground, and lead isolation. Check the technical specs for a comprehensive list of all available tests for your standard. For ECG and performance waveforms, tests include ECG complex, triangle, sine, square, pulse, and VFib. The 𝒎𝒂𝒐𝒓𝒕𝒂𝒏𝒄𝒆 is equipped with 5 applied parts jacks as well as 5-to-5 banana jack adapters to make ECG connections a snap. Simply plug the device you wish to test into the equipment outlet, then select the test to be performed by pressing the appropriate button and following the on-screen guide. If you need to test more than 5 applied parts, the 1210 adapter box is provided as an optional accessory. Here we're performing leakage tests using the 𝒎𝒂𝒐𝒓𝒕𝒂𝒏 connected to an ECG monitor via the 1210 adapter box. This allows for the RA, LL, LA, and RL leads to be isolated from each other and from the remaining chest leads, which are shorted together. For IEC 62353 applications, you can test all 14 leads for leakage using the selection that ties all 5 analyzer jacks together. By grouping the applied jacks just so, the 𝒎𝒂𝒐𝒓𝒕𝒂𝒏 allows you to test 3 separate groups of single function parts simultaneously. To further simplify your testing, the 𝒎𝒂𝒐𝒓𝒕𝒂𝒏 can be automated with Fluke Biomedical's Answer automation. Automating your testing procedures will ensure compliance by standardizing testing procedure to your requirements. An electronic template you create will guide users through a step-by-step testing process, while Answer automatically and electronically extracts data, assesses pass or fail against your specifications, stores data for future use, and generates professional test reports. You can familiarize yourself with the beneficial features of Answer by either downloading a demo version from the Fluke Biomedical website or from the demo CD included with the 𝒎𝒂𝒐𝒓𝒕𝒂𝒏. To access complete functionality for automating the 𝒎𝒂𝒐𝒓𝒕𝒂𝒏, Answer is available for purchase separately. The ergonomically designed 𝒎𝒂𝒐𝒓𝒕𝒂𝒏 weighs in at a mere 3.5 pounds. The power cord is removable for safer storage, and it all stows away into a soft carrying case for taking the unit into the field. The ESA 612 has been rigorously tested to the highest standards in quality and safety for CE and CSA listing, ensuring that the unit will not be dangerously affected by EM fields, electrical static discharge, humidity, misuse, or physical abuse, up to and including getting hit by lightning. With the ESA 612, you can rest assured that you have a rugged and reliable instrument for your electrical safety needs. The standard accessory kit includes test leads, alligator clips, and probes that boast a Cat 3 rating and double insulation for your safety. A USB cable is provided for uploading test results from ESA 612 to your computer, with the data viewer software available free of charge from the Fluke Biomedical website. You'll also find an operator's manual CD and a hard copy guide to get you started. Additional accessories include an adapter kit for North American 220-volt testing, which can be purchased separately to meet any other testing requirements. The ESA 612 Electrical Safety Analyzer is the next generation in biomedical equipment testing. Portable, multifunctional, and reliable. The ESA 612's versatility will simplify testing, increase productivity, and help you ensure compliance with the latest worldwide standards in electrical safety. For all the tests you need, the ESA 612 is the tool you want. For more information, go to flukebiomedical.com.
Yeah, thank you. Thank you for sharing this video. We will have a question answer session, maybe the later stage in the after this session. Now we will be sharing slide for again the same one. Now we have other standards of medical devices. For all equipments, standards are different. Like if you see on this slide, medical electrical equipment, particular requirements for basic safety and essential perform X-ray equipments. For all radiation management equipments, we have these kind of standards are there. Then hospital beds and chairs. Then you have incubators, warmers. Like all those standards are different, and for that you have independent equipments for each standard to fulfill. What are the hazards of untested medical devices? Electrical shock for patient and staff. See, if you don't test, calibrate the equipment, so you cannot be sure that it will be electrical shock proof or like that. So you will have to face all those things. Then electrical shock for patients and staff, radiation injuries for long term. Suppose if you have a CT scan is there, if it is a excess dose is there, what will happen? Radiation injuries and long term negative effects for patient staff. Maybe they will suffer from cancer also later on if it is excess radiation. Device failure or inaccurate performance leading to misdiagnosis and treatment of patients. So this is what I was saying. If you don't properly test, calibrate, misleading informations will be there from the equipments, and unnecessarily will be taking medicines, treatments and all, which will be of no use for a patient. High costs for healthcare facilities associated with device breakdowns, patient lawsuits and workflow inefficiencies. Like suppose if it will be hampering the image of the hospital also. Sometimes they will be sometimes into this kind of legal issues and all. Then medical device manufacturers may have to do a product recall. Now see, imagine if you don't follow the standards and all, what will happen? If suppose there is a company who is distributing 1,000 ventilators. if something happens wrong, if they have not done properly testing and calibration of those equipments, what will happen? They have to recall the product, whether it is in India, whether it is in China, whether it is if the manufacturer in US, he is bound to take all those things back and supply the new equipments to the hospital. So those are the hazards of untested medical equipments. So don't leave medical device untested. What will happen? So this is a published data. Suppose there is a long surgery which was happening as a we can say cardiac surgery. So what has happened is, this one electrosurgical unit was there. There was a leakage for 4 hours continuously going on. So what has happened? It has given a 3rd-degree burn to a patient. So these things we can avoid. That is why I said it should fail. Equipment should fail in a biomedical engineering department. It should not fail in the OT. It should not fail in ICU. It should not fail on patient. So this is our responsibility. This is a biomedical. Actually, we can say the tagline for biomedical. They are the custodians of the hospital assets. They are the custodians, and they are responsible for all those things, maintenance, all those, whether equipments are working properly or not. They have to ensure all those things. Otherwise, quality and it will suffer always, and there will be always, patient will be at losing end always. So same as I mentioned, CT radiation overdose was there. So he has got all those, side effects then. So testing is really very important. We say, okay, we have got a Mercedes car, we have got a BMW. It is from a BMW. What will happen to this car? Nothing will happen. Oh, but still we are doing servicing after 5 years, after 5 months, 6 months. Then we are talking about here medical equipments, which are taking, those are life-saving products. So we are just leaving them like that only. So regulation is something different, but responsibility, accountability of a person is something different. If regulation is not there, that doesn't mean that we will leave equipments like that. We will play with the, people, we will play with the people's life and all. So please ensure that whenever you go to any hospital, because you will be taking good jobs after you complete your all those engineering courses, please ensure that be accountable at your place. Just try to contribute in a best way whatever you can, and try to deliver for the society. That is the ultimate. You don't require regulations from the government. Abhi piche se regulation hai, then only you can do. No, it's not required actually. You can convince your management. You can talk to your hospital management. This is the thing. That is the thing. Like as I said, infusion errors can be deadly if simple safety steps are overlooked. As I told, overdosing, low dosing, missed alarms can lead to patient harm. Like suppose if you are in a ICU, some patient is critical. He wants oxygen. He's on a ventilator, but something can go wrong if missed alarm is there. Something can go wrong with the patient. If there is a properly alarm on the ventilator, then sister or doctor, they can go and see what is happening around. Those are very small things. And even for whether the oxygen is going properly or not, if we have set 80%, whether it is 80% or 50%, so those things you can really cross check. Now let us in the back we have seen electrical safety testing we have done. So that was when the equipment is there, whether it is safe for patient use or not. So that is a common testing equipment, testing protocol for all the biomedical equipments. Now we are talking about performance tests, individual equipments. Like suppose we have a patient monitor, we have infusion device machine, infusion pump, syringe infusion pump, what we say. If we have a defibrillator machine in a hospital, how to cross check, how to test, how to ensure that those parameters generated by the equipment are working properly. That is also, again, as I said, if blood pressure is not coming properly, you will get a medicine for lifelong. Whether it is required or not, just do a test and you will come to know. But we are not doing any test, but just prescribing medicine. That is the worrying part actually. So let us ensure that all these things are in line, in place. It can measure most of the parameters. We have a product called ProSim. It's the ProSim series. We have different, like it depends upon the applications and all. And the what can you do? ECG simulation you can do. NIBP, SpO2, respiration, IBP, intervenes blood pressure. Suppose if NIBP is basically you are checking through a cuff. Okay, so we have a simulator for so left side I have mentioned in yellow color, it is a Fluke product. It is a Fluke testing equipment. Then right side I have mentioned just for your this thing for your understanding that this is a monitor. This is a patient monitor which is used in hospital. So what can you do with this equipment? You can have BP instruments, ECG instruments, multi-parameter monitors. If it is a combined like ICU monitors, TMT machine, pulse oximeters, lot of things you can do. Infusion device analyzer. We have an analyzer. You can check the infusion machine like same right side. I have mentioned this is a image of infusion pump, hospital infusion pump, and this is our instrument to test. What can you do? Volume, flow rate. As I said in the previous slide, that test will be the, that protocol will be same, standard will be same. Only you have to follow. These parameters should be accurate. These parameters should be within the permissible limits. Volume, flow rate, occlusion pressure. Then defibrillator analyzers. As I said, this equipment is very critical because it will be there in the emergency. Sometimes what is happening is patient doesn't come for a longer time. Like वो emergency में ही आएगा patient. If he comes after 5 months, but normally the trend in India is what is happening is these once the patient comes, these defibrillators are not working because sometimes it runs on battery and that battery is gone. Nobody has charged those batteries. Then once the shock is to be performed, it is not working. Then what we are saying, oh patient, you have come late. But we are not blaming ourselves that our equipment was not performing. But if I say, if doctor says, oh, equipment is not working, then he will be behind the bars. So we don't want to do all those things. We just want to blame only patient that he has come late. And this is my request to all the students here, all the faculty members, whoever has joined in this session, please understand the criticality of this particular product. Ensure that whenever you get job kind of this, like in a biomedical departments, please ensure defibrillators are working. It should work every day. It should work first time and every time. It should not work only in a 6 months once. It's like that we are taking food today, tomorrow also we have to take the food. Same is the case. We have to follow the protocol with this defibrillator also. Once we come, we check whether it is working or not. That is the thing. So all those things matters for a patient. So you can check all the defibrillators, monophasic, biphasic, all those things you can check. Same ventilator analyzer, we have this. No, right side I have mentioned this is a ventilator, and our equipment is VT650. It's a gas flow analyzer. So all those parameters it will check, like what are the pressures, what are the flow rates, what are the volumes, time ratio, inspiratory expiratory ratios, and apart from that you can check other equipments also, like CPAP. Like recently, if you see, ventilators and oxygen concentrates were in a huge demand in India because of this pandemic and all. So this particular equipment was having a very good demand in the market for almost for now. Still, it is going on. So they are using all the this equipment for their testing and all those things. Manufacturers, hospitals, all those things. So just ensure that all the parameters are working fine. Then hand over that equipment to anyone who is working on ventilators. Similar thing with electrosurgical unit analyzers. So you test all those cautery machines in the hospital. What you have to cross check is whether the power distribution is correct. If I am saying it is a 400 watts, whether 400 watts is there or not. Current, frequency, load resistance ranges as per IEC standard. We are not talking about anything which is not as per the standards. It's all we are following the global standards. So fetal heart simulator, like suppose if you might have seen, in gynecology, when pregnant women are there, they go for a routine testing of ultrasound. So sometimes what is happening is whether if he is having a twin also inside, it will tell that also. Mechanical fetal heart is there. It will check that also. Like TOCO simulation is also there. Ultrasound simulation is there, including twins. Suppose if two babies are inside, it can detect heartbeat for both also. Fetal ECG, whether the heart rate is working fine for not for the baby, it is basically the fetal heart monitor, which is going to be put on a pregnant woman. You have to check that machine. If that machine is giving wrong readings, so you imagine what will happen to that lady and to his baby who is there in the fetus. So these are very critical equipments. So we have to ensure we cannot leave any equipment untested. We have to test each and every parameter before it is on use for the on patient. Arrhythmia selections, we can check whether it is a tachycardia, whether it is, we can check all those, arrhythmia is ECG arrhythmia selections. Fetal beat to beat variability, there is an option in this. You can simulate all those things and you can check, you can test all those. Same way, phototherapy analyzer, whenever there is a jaundice is happening, so what is happening? They are giving that light and to normalize that kind of that disease. So for that also we have a instrument like DALE 40. It will test the full spectrum range, whether within that wavelength that kind of intensity is there or not. Otherwise, phototherapy, giving phototherapy unnecessarily which is not giving any result is of no use. Same way, incubators and radiant warmers, we have these two. We have a single instrument which can test all the modalities for temperature, humidity, sound, airflow, all those things. You might have seen, you might have heard about one incident which had happened in Rajasthan just 1 year back, about that this newborn baby, 3 months old, got burned in incubator, hospital incubator. They said it is an electrical shock. It is a shock short circuit, and it has happened like that. But actually, if you see the truth, if you go into the deeper kind of root cause analysis, you will come to know it was actually temperature got rise up to 50 degree. So that is a kind of that is a quality problem, quality issue with the incubator, which they have not monitored, they have not tested, and this newly born baby got burnt fully, and he died. Can I have the video for patient monitor testing by our simulator?
Yes, sir.
Yeah, let me unshare this one. Yeah, please.
Patient monitor testing can be quicker and easier than ever before with ProSim 8 from Fluke Biomedical. We're going to do a patient monitor test, and we're going to try and do a complete but quick test of this patient monitor. The parameters we're going to test are ECG rate, respiratory rate, invasive blood pressure, channel 1. We're going to do a cuff blood pressure and IBP measurement and oximetry. We're going to try and get all of this testing done in under 5 minutes. As you can see, there's a digital clock shown in the lower left-hand corner of the patient monitor display. So you can be your own judge as to whether we can get through this test within 5 minutes or not. So as I begin the test, we are already connected to the device under test. All of the connections have been made ahead of time, including the NIBP cuff. And we are going to zero our invasive blood pressure transducers on the patient monitor at the very first step of what we do, followed by a selection of a simulation of all coordinated patient parameters. We'll do hypertensive first, followed by normal, followed by hypotensive, in order to assess whether we have a performing patient monitor. We will compare the displayed values on the ProSim 8 against what's displayed on the patient monitor at each set of simulated parameters. Are you ready? Let's begin now. First thing I'm going to do is 0 P1. It is at 0. And now what I'm going to do is pick hypertensive. And the simulation will already begin, so I'm going to start a blood pressure, cuff blood pressure reading. In this case, we're looking for an ECG rate of 130 beats per minute, respiratory rate of 40. We're looking for an invasive blood pressure display of 200 over 150. We're looking for NIBP of 200 over 150 with a mean of 167, and an SpO2 reading of 90. And it looks to me like we've got all of those on the patient monitor. 130, invasive blood pressure 198 over 149 with a mean of 167, and we have 90 O2 sat and 197 over 142 with a mean of 165 on the cuff. Let's move to normal. The normal simulation includes heart rate, ECG rate of 60 beats per minute, a respiratory rate of 20 breaths per minute, invasive blood pressure of 120 over 80, a cuff blood pressure of 120 over 80 with a mean of 93, and SpO2 at 100% O2 sat. As you can see, the patient monitor is already displaying 60 beats per minute for heart rate. It's gotten 119 over 79 with a mean of 93 for invasive blood pressure. And the cuff is making its measurement now for the O2 sat, or for the NIBP reading. O2 sat is 100%. There we go, 121/77 versus 120/80, pretty good. We'll go to hypotensive now and start another cuff measurement. We're looking for an ECG rate of 40 beats per minute, respiratory rate of 15 breaths per minute, and invasive blood pressure measurement of 50/20, and cuff blood pressure of 50/20 with a mean of 30, and an O2 sat of 97%. You can see that the ECG rate on the monitor is already 40. Our invasive blood pressure is 50/19, very close to 50/20. Our cuff is working on getting its measurement, and the O2 sat is 97, right on with what we asked for, what we're simulating. We started at 18:55 and 44 or 45 seconds, and we're going to finish very shortly here. Done. And we have good values. As you can see, it is possible to do a complete, quick assessment of patient monitor performance using ProSim 8 and front panel controls in under 5 minutes.
Thank you. Thank you for sharing this video. Let me share again. Can you see? Yeah. So I just want to inform one more thing here, and to the all participants. Okay, there is a Fluke Advantage training. It is a very good knowledge center for. If you can log into this, if you can register, but please, you have to come through your HOD, who can compile. Then they can send it to us, that list, and you need access to attend all those things. Then once it comes to us, we will ensure that your access is through. Then you can start working on that thing. There is you have to actually passing criteria is 80% in that. If you have done, but you have to really see all those slides and all, then you have to qualify that. And 80% if you score, you get a very good certificate from Fluke, that you have got this training completed. So please, I request everyone to register yourself on that this one Fluke Advantage training portal, and you will get a very nice certificates. And first of all, whatever the knowledge is there, that will be very useful for you. And let me share that. If you want, I can guide you how to do that. So let me show. See, I am going to, this is a live, it's this one. If you go to Fluke Biomedical, www.flukebiomedical.com, then go to Knowledge Center, Advantage Training, then come down, get training now. This is the process. Then register, put all the details here, all the required details, then go to next. Then it will ask some more details. Then again, you have to submit. Then it will come to us. Then in the meantime, you can send your informations to Dr. 𝒒𝒐𝒓𝒕𝒂𝒏𝒄𝒆. Then he can forward it to us. so that I can also forward it to US for getting the access for you. So so now this form is open for thanks for your kind attention. Any questions, please? Can you see?
Hello, your screen, are you showing something? Yeah.
Yeah, it's
Now we
okay.
can, yeah.
Yes,
Yeah,
Have
we
you
can
seen
see.
that advantage training I was just saying, no?
Yes, sir.
Hello?
Yes,
Oh,
Yes, it was
that
visible.
live I was showing, no? That you have seen?
yes, it was
Yeah,
visible,
okay.
sir.
Yeah, okay, fine. So now the session is open for any questions. Thanks for your kind attention, dear audience. So yeah. Shall I stop sharing and let's start? Yeah.
so it was a great session, sir. Quite a
Thank you.
informative session.
Yeah, Raina sir, I have one question. Yeah, so we are using this Fluke biomedical equipments for testing the medical equipments. But are these equipments are tested or calibrated? Your equipments?
Yeah. No, you are using some of our products or not yet?
No, yeah, no. We long back I used to use
Yeah,
your some of the
see, that is
products.
a very
My
good
question is,
question. Yeah, I
yeah,
got it. That is a very good
yeah.
question, which I was expecting. See, normally when we are talking about hospital equipments testing, and the question in mind is, what about Fluke biomedical equipments testing? Okay, calibration and all. We have a full-fledged lab in Maharashtra, Mumbai, Thane, Maharashtra, and where we have all the assets, and you can calibrate and our equipments in that lab. See, suppose if I am saying, if electrical safety analyzer is there, suppose if I am saying, roughly it is costing 5 lakh rupees. So for doing calibration for electrical safety analyzer, we should have an asset of around 50 lakh rupees. It should be 3 times better than the accuracy what we are trying to do. Okay, so that asset is there in the Thane lab. So for all our equipments, if you want to do calibration of our equipments, that is possible. That can be done at our Thane lab.
Thank you. That was the one of the dot because once that is
Yeah,
the foolproof system. Calibrating
yeah, that's
equipments are
good.
also calibrated, and you are using the calibrating instruments to calibrate
You
or
get,
test the
yeah,
medical
you get
equipment. Yeah.
full chain of that traceability and all.
But is there any frequency, sir, to check the
See,
calibration?
normally it is because these are all life-saving products. Normally we say for some equipment 6 monthly, but normally 1 month, 6 monthly, and otherwise 1 year is sufficient. Yearly it has to be done.
I think some of the equipments they are seen in third year of engineering. Some of them they are about to learn in their final year of engineering. So maybe from next semester onwards, they'll be interested in going details because they are now just learning in mode of fundamental about that equipment. So once they
Correct.
get an idea, this will be used for them for further testing. So
Correct.
definitely, we'll share the list with you soon, the Excel
Yeah.
sheet. So then, and one important thing I want to tell you, all the colleagues who are interested to do the career in biomedical engineering, these certificates from Fluke Biomedical makes an added advantage to your CV.
Correct, correct.
Because once you joined, once you
They
joined
can
any
mention
company,
resume.
yes, joined the company or any hospital, and the authorities know that okay, you are aware of this testing
Yeah,
equipment,
correct,
so it
correct.
takes a
That
great
is
weightage
that,
out of it.
correct,
So
correct.
they are
That's
good for your placement point of view. That's what
and
I
also
wanted to.
that too also if you are having a Fluke certificate, and that is
Yes.
it shows that you have done it very this thing, and the preference will be given first to them in that way. That is the because this Fluke is a we are the as you say, we are the standards in this field.
Yeah, and maybe Renas, I
Yeah.
want to add on not only in biomedical equipments, we have all our Fluke, even multimeters also there,
Yeah,
even
correct.
Fluke are there in
Electrotechnical
all the
pressure everywhere. Yeah,
yes. They are used in various industries, even chemical industries, water industries, everywhere the flow testing are there. So it's a very
correct.
vast and big area of testing.
True.
I think there is one question from Rutuja.
Yeah.
Yeah, Rutuja, want to ask directly or shall I narrate the
No,
question?
she can ask directly. No problem.
Rutuja.
Yes, sir, I can read out. Can all defibrillator testers test the full range of human transthoracic impedance?
Which one?
Can all the defibrillator testers test the full range of human transthoracic impedance?
Yeah, see, impedance is basically that is a different product. But normally here, what we are talking about the load resistances. Load resistances you can do, but yeah, load resistances you can do. You can do energy calculation. You can do energy measurements with our equipment, and you can do discharge and charge time. You can measure.
Okay.
Thank you, sir.
Sir, so if there are no questions, can we move forward?
Yeah, you can move forward. Any questions are there? After that, you can mail it to us and we'll forward it to Raina
Yeah,
sir
no
also
problem.
later on. Yeah, that will be the best thing. Yeah. So yeah, we can go forward. Yeah.
Okay. So I'm sure our audience is very happy with the session and the webinar. So that was quite an intriguing and inspiring session right there. I extend my gratitude to our honorable speaker, Mr. Deepak Raina sir, for taking out time from his busy schedule and to grace the event. Thank you so much, sir, for
Thank you.
inspiring and encouraging
Thanks for
us.
inviting me. Thank you very much.
Thank you, sir. It was pleasure having you.
Thank you.
Now I would ask Rutuja and Ananya to take over for the closing session. Okay, sir. So
Yes,
before that,
yes.
I would like to request everybody to switch on their cameras for a picture.
Yeah, it's done.
Okay. Thank you so much, everyone. So now I'll hand it over to Ananya and Rituja for the closing ceremony.
Hello, Rituja, can you
Yes,
hear me?
Ananya, you can. Yeah.
So, as we are at the end of our 30-hour credit course, that is PMESI sponsored certificate course on medical device manufacturing and regulation, I, Ananya Pingle, General Secretary of BMESI, would like to reminisce our whole journey, which was started with a brief introduction on medical devices manufacturing and regulation by Mrs. Shreya Kulali, who discussed about the current development, also the developments of surgical and diagnostic instruments and regulatory system in launching these instruments. Our next session was conducted by Mr. Kalpesh Patil sir on a very emerging topic in healthcare, that is AI and ML in the healthcare system, where he shared different types of biomedical signals and their processing techniques. Also, he spoke about importance of AI and ML in medical diagnosis, treatment, and its various applications. He also demonstrated ML models and signal processing with Python for us. Later on, with more than 24 years of experience in the field of biomedical, Mr. Nilesh Shinde sir, the CTO of Jupiter Hospital, shared his experience and motivated the future biomedical engineers with a very informative session on medical device safety, their safety checks, maintenance, quality assurance, calibration, and much more. After this session, Mr. Dali Kuriakos discussed the most important topic in the field of biomedical engineering, that is, the regulatory framework for medical devices. He also gave us a global perspective of medical device regulations that are being followed for the evaluation of biomedical devices worldwide. Further, giving us hands-on workshop on various IoT-based projects by our very own Mr. Anand Panchal, alumnus of VIT, enlightened us with all the basics of internet and sensors. He also gave us live demonstration on IoT-based projects using HTTP and Arduino. And today, in on our last session on the importance of biomedical device testing by Deepak Raina sir, he spoke about how important it is to test devices for patient safety and what are the hazards faced during these tests. It was an amazing journey. I would like to thank all our honorable speakers. We are very grateful to you all for sharing your knowledge and experience with all of us. As future biomedical engineers, we are truly inspired by each and every one of you. Thank you so much for your efforts and time. Hoping that we have more such wonderful sessions in the future. On the behalf of Department of Biomedical Engineering of VIT and BMESI
And BMSA, I would like to extend my gratitude to all of you, Honorable HOD 𝑗itendra sir, respected conveners, Professor Geeta Narayanan ma'am, Professor Neelam Punjabi ma'am, Professor Arun Kumar Ram sir. It is such an honor for me to get the opportunity to thank you all the dignitaries. On behalf of the Department of Biomedical Engineering VIT, I extend warm thank you to all the professors and attendees. I would like to express my gratitude to all esteemed delegates of the webinar for their presence and contribution to make the webinar a great success. A special thanks to Dr. Jitendra Zoravi sir, HOD of Department of Biomedical Engineering, for providing immense support to make the webinar successful, and all the three conveners for having such a great speakers and guiding us on each and every step. We appreciate all the efforts taken by you all to make this 30 hours credit course a huge success. I would now like to thank management of Vidyalanka Institute of Technology, all the faculty members, BMSA and BMESI committee, conveners, and you participants for making this webinar a successful one. Before ending the session, I would like to conclude by a quote expressed by Brain Harvard, that is, the capacity to learn is gift, the ability to learn is skill, the willingness to learn is a choice. So, keep exploring and acquiring knowledge and pave the way towards your dreams and passion. Hoping to see you soon. Over to you, Ananya.
Thank you so much, Rituja. To all the faculty members and everyone, we are very thankful to you all. We would like to end the session by playing the national anthem. So,
Hello, hello. I would like to say a few words. I wanted to say a few words about the BMSA committee and BMESI committee. They were really, actually, it's amazing. Actually, they took over as the members of the committee and as a GS and as a president of BMSA, you have taken up, and you are given with a very big responsibility. We know that you are very young students, and we gave you a bigger responsibility of doing it. And Rituja and Ananya both, I should say, they said, we will do it. And they did it actually. And with the way they were coordinating, I know that when it is a team, there will be many problems associated with it. And you feel that this person is not working, this person is not working, or this person is doing more, or something like that. But everything was handled very nicely by both of you. And it was really, I should remember that around 11:30 also Rituja will message me, this is okay or not. That means they are working throughout night also, they are working and doing it for the success of this event. So it was really grateful. We are really grateful. I think Neelam Punjabi ma'am also will vouch for it actually. It is really,
Yes, ma'am.
yeah, it was really
Yes,
nice of them. Anytime they will call and ask what to do, and whenever the next event is there, they are more worried about than us actually, what we should do, what should be the poster. They keep on calling the people in the technical team and in the creative team to find out to make the poster, to get it approved by the speaker. Everything was done so nicely, and it was we expect the same type of teamwork from you for the next events. Next semester should be a fruitful event. There could be differences in between members that we can understand, because when you are working in a team, you will come to know, and that this is the platform you are working actually, to work also you are getting. So you have overcome everything. Now I think you can do any work. I feel like that only now.
Yes.
Yeah, they can do
Well
any
done.
work now.
Well done,
Yeah, well done.
BMSA entire members, all the members, BMESI, all the members, and also the core heads. Okay. Well done, everyone.
Yeah. And I would like to say one more thing. Mr. Anand, he is our alumni. He, after the session, he announced that there will be a prize for the best attendee of his session. Best attendee, I should say. Best attendee in the means of a chat and in the means of the test also he conducted. So he assessed himself the chat box, and he assessed himself the test marks and the responses of the test, and he gave the winners. You can announce the winners here, and they will be getting what is that, 32 na, ESP 32 as a prize. So he sponsored it for the biomedical department, and it will be given to you if you are sending. The winners will be announced now, and if you are sending the address to us, we will be sending it. Arun Kumar sir, you can also be present for this gratitude towards the students. You can also switch on camera if you can, and then you can also share your thoughts. Yes, Neelam ma'am, you can share your thoughts.
Congratulations to both the winners. Okay, and thank you all the participants for joining for different events. Okay, thank you so much. And the winners can give the address uh, to our team members. Okay, they will send the prizes to at your residences. I think ma'am Ramsar.
You can announce the winners, Ananya or Rituja, whoever is having the winners, you can announce.
Sir is there?
yes,
Hello.
yes,
Deepak sir.
Deepak sir is there, sir.
Yeah, maybe if we have finished our program, we can. If he wants to go and he wants to do some work, he can leave the meeting. It has become a little more internal. Deepak sir. Hello, can you hear me? Okay. Yeah. Right. Please continue.
Yes, sir. So the winners in the order. First winner is 𝑰𝒎𝒑𝒐𝒓𝒕𝒂𝒏𝒄𝒆, and the second is Pratyush Raut. So if they are there in this meeting, they can speak if they want.
Congratulations, guys. The prize will be delivered to your doorstep. Please share your address with us so that we can get it delivered to at your place.
We'll contact you soon. So please just call. Thank you.
Okay, congratulations, Rishika and Pratyush.
Yeah. Can we put their names in the chat box so that everybody will know? Is it possible?
Yes, sir.
Yes, sir.
Yeah, so that they will also come to know. Maybe suppose they are not present, they will also come to know. Yeah.
And there's just a bit of information about the certificates. If you have attended all the sessions, participation certificates will be provided to you all accordingly. And the course completion certificate, if you were sincere and if you have been there in all the events and you have filled all the feedback forms and quizzes, you will soon receive the course completion certificate. Thank you.
Yeah, about the course completion certificate, we will see the assignment also. So we will be having some criteria for that, and we will try to accommodate maximum participants. Don't worry, we will try to accommodate maximum participants with the certificate. Thank you for joining, and please join our upcoming courses also. Next semester or next year also we may plan courses. So I am expecting all the guests and the participants from outside VIT also. Please join the event.
Yes, ma'am. Thank you so much, everyone, for being there with us. Hope you stay home and you stay safe. Thank you.
Ananya, are you playing National Anthem?
Oh, yeah. Sorry. I forgot.
Yeah.
1 second.
We will be ending the session with the national anthem. And
Can I share?
yeah.
Yes, Gaurav. You can share the screen. Yeah.